Hello, welcome. Hope all is well. My name is Kasasa Charles Derrick, and this is the number plate recognition machine learning project or AI project. So there is a strategic increase in vehicles and motorcycles on the roadways of cities in Uganda, and this has stimulated a high demand in technology for traffic monitoring and management. So a system using artificial intelligence would play an inevitable role in systems like the parking management systems, and then the toll payment, like the one we have at the Kampala Entebbe Express, which would save a lot of time in turn, and time is money. So artificial intelligence in the number plate recognition. So we have the NPR already, and automatic number plate recognition. So to be able to implement the number plate recognition, you would have to apply image recognition, which is part of the computer vision, which pertains to identifying objects within an image or video frame. So the kind of data I'll be using for the project, I'll be using images and video frames, as I mentioned. And then what's the difference between supervised and unsupervised learning? So supervised learning involves algorithms that work on or are trained using labeled data, while the other unsupervised learning, they are trained using unlabeled data. So supervised learning model predicts the output, while the unsupervised learning model finds the hidden patterns in the data. And then supervised learning input is provided to the model along with the output, while the input, we only provide input for the unsupervised learning model. So think of the supervised learning as having your teacher there with you in class, and then the unsupervised is self-study, as the students are trying to learn on your own. And then there are more differences there. Then supervised learning techniques. So supervised can be grouped into two categories. So I'll be using the regression. So in regression, a single output is produced using the trained data. So this values an interpretation which is seen after considering the strength of correlation among the input variables. And then with classification, to be specific, the image classifications. So this can be binary or multiple classifications, means categorizing data into more than two classes. So binary, it's categorizing them in two classes, then the multiple would be more than two classes. And we'll see that during the course of the project. So in unsupervised learning techniques, we may have the clustering. So this deals with finding a structure or pattern in the collection of the uncategorized data. And then the association rules. This is unsupervised technique. It's about discovering interesting relationships between variables in large databases. And then the AI challenges that I would face in a project like this. So the project would require a certain level of expertise in structural accuracy, and then it would require it's time intense. So that's for the case of the supervised learning, and then selection of the best algorithms and data sets to use. So finding the right data sets to train, and then test out maybe the different algorithms to see if everything is working. So in the solutions for the problems that I've seen, so I'll try to select the best performance metrics to verify if my project is actually doing the desired role. So be aware of the algorithms I choose, and look at the different algorithms, both the supervised and unsupervised models. So what's the difference between accuracy, recall, precision, and the F1 score? So these are performance measures, and accuracy is the most intuitive. It's simply the ratio of correctly predicted observations to the total observations. Then precision is the ratio of correctly predicted positive observations to the total predicted positive observations. and you could see the mathematical formulas there. Accuracy is equal to TP, where TP is the true positive, and this is from the confusion matrix, where TP is the true positive and TN true negative, then FP false positive, FN false negative, and then precision down there, we said it's the predicted positive observations, which is the true positive over the total predicted positive observations. So recall is the ratio of correctly predicted positive observations to all observations in the actual class. And then the F1 score is the weighted average of precision and recall. So you need to know about precision and recall, and then calculate the F1 score. So the two evaluation metrics for the projects that I would use are the accuracy and the confusion matrix. So we talked about I mentioned the confusion matrix back then. It's a tabular visualization of the ground truth labels versus the model predictions. So for the references, I've looked at the Java T point, where they have some good articles about the supervised machine learning. Then I also used the Tech Target, and then a YouTube channel that's from Free Code Camp, machine learning for everyone, which was a 3-hour course and a great one. So thank you, and that's it from me. See you in more of these videos. Bye.